suggest that you run off the foldable first, go in and cut it out and fold it, and then get back to the video. Flip it as you go. So here we go, parabolas. Do you know off the top of your head what makes parabolas? What kind of equations, what kind of functions? Quadratics, very good, quadratics. So here we go. So here are the things we're going to cover 4.1 and 4.2 today. Let me write this down just to give your brain someplace to organize. We're going to graph quadratics using our AH and K knowledge, and we're going to graph them from all three forms, because just like with linear and algebra 1, you had the the point slope form, the standard form, and the slope intercept form. Well, in quadratics, you have forms as well. They're not called the same as what you have in linear, because we have standard form. That standard form is the standard in any kind of function. It's going to have A, B's, and C's in them. But we have a vertex form with a parabola, because the parabola has a vertex, the line doesn't. And then we have factored form, which linear does as well. So some of them will look unfamiliar, some of them will be new. Actually, you've had all of this in Algebra 1B. Some of you will have mastered it already, and so this will be a review. For the others of you, hopefully it'll be an aha moment where we'll finally kind of get back into the long-term memory. All right, so let's think about quadratics in general. What would a quadratic look like, the parent function of quadratic? First of all, by definition, a quadratic has an x is going to be to the second power. That's the, woo, here I am, I'm a quadratic because I have a squared on my x. That's what identifies it as a quadratic. So, and you know that the parent is a parabola, but let's talk about logistically, so that you can produce this anytime. Since it's just x squared, you could, anything you put in here, let's say we go from negative 2. So we negative 2, negative 1, 0, 1, 2. Whatever you put on this side, you're going to square to get here, right? So we're going to square negative 1 and get a 1. Because since you're squaring something, it doesn't matter if you're squaring negatives or positives, you're always going to get a positive. Square 0, square 1, square 2. So that means for every time you go over to the right 1, you go up by its square. So 0, 0 squared is 0. 1 squared is 1. But 2 squared is 4. 1, 2, 3, 4. And then 3 squared is 9. So 2, 4, 6, 8, 9. So it starts jumping up a lot faster because you're squaring every time you square the x every time. And of course, it will do the same here. With the negative 1, you square negative 1, it's just a 1. But you square negative 2, and it jumps up to 4. You square 3, it jumps all the way up to 9. And therefore, you can't make a v out of that, because a v has a steady slope, whereas a parabola does not. If you started drawing a lot, v like that, that's not a parabola. That is your v. That's your absolute value. So that's why it causes a curve, because you're all of a sudden y go up pretty fast. Okay. We're going to refer to, we talked in the past about your parabola or your v, that's a value, opening up or down, but we're going to kind of use a bigger word, more mature word now. We're going to talk about concavity. You probably have done concavity in science. You've got concave, and what's the other one? Convex, yeah. Well, obviously a parabola would have a concavity. And so in this case, we're going to say it's concave up. Instead of it opens up, we're going to say it's concave up. Of course, the vertex is 0, 0 in this case. Every parabola will have an axis of symmetry, just like our V's did. That shouldn't surprise you. Symmetrical on both sides. So our AOS, sometimes I put AOS for axis of symmetry. Sometimes you'll see LOS for line of symmetry. Same thing. But it's a vertical line, so what's the equation of a vertical line always start with? An X or a Y? X. So this would be X equals 0, meaning this vertical line right here. The y-intercept, how do we find our y-intercept? We set the, what equal to 0? To find the y-intercept, you set your x equal to 0. To find your x-intercept, you set your y equal to 0. Good. So to find our y-intercept, we set our x to 0. And when you square 0, you get 0. We've talked about minimum and maximum values. Well, not exactly. We talked about minimum and maximum points. But now we're gonna add this piece value. Minimum and maximum value. The value is the output of a function. You know, we've always talked about the analogy of a function being just like a machine that you're putting something into. So if I put a bunch of gold and metal and whatever into a machine, what comes out? Maybe a lamp comes out. Okay, this, no, that's crazy. I just made that up. Can you tell? This is what we're looking for when we say what is the minimum or maximum value. What we're asking is what is the minimum or maximum output. Okay, so we don't want the x and the y of the vertex. We only want the y of the vertex. We don't want the output of the vertex. So the minimum value for this problem, since the vertex is at 0, 0, this right here is the minimum output. So it's going to be 0. Minimum value is 0. What did DNR stand for? Domain range, of course. So and we'll do that in interval notation. So you should be getting really good at that. How far left will she go? Negative infinity. How far right? Okay. How far down? Okay, including 0 to infinity. So that's just a basic lesson on parabolas. You should know all that. It's so similar to absolute values that should just be almost like riding a bike. Maybe just a little different take on that, and this a little bit different take. But other than that, it's all very, 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 very similar. And by the way, the tests that I've graded so far have been excellent. I probably have in this class so far 6 that are over 100%. That's really rocket. All right, so let's get into the individual forms. Okay. Did I totally not do the hooks? Stand first, but maybe not. So we'll start with vertex form. So look on your foldable. Where is your vertex form? Which flap is it? First, second, or third? Second one. So go to your second flap. Make sure you're on your second flap, or this will get really confusing. This is the vertex form. Y equals 8, parentheses, x minus h squared plus k. Sure looks familiar. And on your foldable, it says the things we know directly from this form. This is what we know. We know the vertex, right? Because it's the opposite. It's the opposite of what's in here and exactly what's out here. So we know the vertex directly. We know the axes of symmetry directly. Actually, you know what? I'm going to let you in a minute to copy those down and we'll talk about them. So our vertex is HK, axis of symmetry, x equal h. Concavity, if A is positive, it opens up. If the A is negative. We haven't really talked about this factor business, but let's talk about it today. What will A, if it's a shrink? Well, let's do stretches first, because that's what you can visualize. I can visualize best. Let's think about the putty we talked about, the putty that you can play with. If you stretch it this way, is it getting skinnier or fatter? It's getting skinnier, right? So if it's getting skinnier, then you'll be multiplying Are you multiplying by a larger number or a smaller number? It's getting skinnier, a larger number, right? So you're multiplying by a whole number, all right, a greater than one factor. That would be for a stretch. Okay, and if you're shrinking, if it's shrinking, then is that thing, is your graph getting fatter or skinnier? Your shrink's getting fatter. Wait, what did I just do? I think I just did that backwards, didn't I? Because when it's getting skinnier, yeah, you're multiplying by a big factor. That's right. And then when you shrink it, it's multiplying by a factor that's a fraction. So you're multiplying by like a half or 3/4. That's what your A would be. All right, so let's do one of those. So open your flap, and you should have a place where you can write the problem up top, the different pieces to it, and then we'll do the graph in the middle below it. So you'll have a nice graph. So again, this is vertex form. And our equation is going to be the f of x equal to parentheses x minus 3 squared plus 1. Obviously, 2 is my A, this is my H, this is my K. So I'm going to help you keep on track. So my concavity, my A is a positive, therefore what are you going to write on concavity? Is it concave up or concave down? Up. My vertex on this one? 3, 1, very good. Yep. Axis or line of symmetry always starts with an x equal because it's a vertical line. X equal 3, very good. So it's the x to your vertex. The y-intercept is where x equals 0. Where x equals 0. Well, we'll plug 0 in from x. 0 minus 3 would be negative 3 squared, that would be 9. Times 2 would be 18. Plus 1 would be 19. That's going to be way up there. And is it going to be a minimum value or a maximum value? If it's opening up, that vertex is going to be, is that going to be a maximum or a minimum? Minimum. So we'll circle minimum. And what's that minimum output going to be? It's this. Your vertex. It's actually the output of your vertex. The output of your vertex. So this would be a minimum value of 1. And actually, I'm not going to graph that much. I can see the domain range better than I can think about it. I'm going to go ahead and graph this and get my domain range. 0, 19, oh my gosh. And y'all can go and start graphing on yours. You've got a graph there. I'm going to just fake it and say this is 19. I don't know. You probably don't have a 19 either, do you? So you can fake it as well. And then our axis of symmetry, of course, will be right there. What else have I figured so far? My y-intercept together. I'm going to go in and get my, do you remember what we called it since this is a line of symmetry? It's on 1, 2, 3 from the axis of symmetry. You'll have to go 1, 2, 3 here. Remember what we called that point in relation to that one? blank point where it starts with C, C-O, C-O-R, corresponding that, and then the corresponding point on the other side. So I could draw it at this point then. So I've got intersect. I'm shadow it, so it's concave up, that's what I would expect. Then we'll do it here. Make sure you're not drawing an absolute value. Drawing a parabola. So now it's easy for me to see the domain and range. So of course it's going to go all the way to the left, so negative infinity or positive infinity of the domain. How about the range? What's the lowest it's ever going to go? Lowest y it's ever going to hit? 1, I think. And then it'll go up forever. So range, that's 3. And that's including 1. 1, 2, 3. And you've got your nice example in your oval, which you can use on quizzes. Any quizzes during this chapter, you can use it. Can't use it on the final test, but you can use it on the quizzes. So make sure that's accurate there. We don't need another one of these, do we? I think we're good. However, just one little quick thing. What's different about this one right off the bat? It's going to open down, yes, and concave down. All right, let's go to standard form. So this would be which window? First, second, or third? First. Make sure you're in the right window. It will get confusing. Notice we're back to our AHs and Ks. So we have A, B's, and C's. They're all numbers. I'm going to give you a minute to write down what we know from here. Okay, so let's go on with our AHs and Ks, what each of these tell us. The y-intercept. What is the y-intercept going to be on this problem? When you set your x equal to 0, what happens? This is a 0, and this is a 0. Those first two terms totally go away, right? So you know that your y-intercept is sitting right out here staring at you. So that C will always be your y-intercept. So your y-intercept will always be 0, whatever your C is. Which is kind of like when you had the y-intercept plus b business in linear. This was always your y-intercept. So it's very similar. That number that's sitting out there by itself is going to always be your y-intercept, because everything else is going to go away because they have x in it. Just like everything went away here when they have x in it. So that's kind of sweet. Okay, and then of course our A will tell us if it opens up or down. Again, if your A will open up if your A is positive, down if your A is negative. Okay, so now we're back to the vertical strength and stretch again. So we're talking about A here. So if it's a whole, let's see, if it's greater than 1, it's greater than 1, what's it going to do? Can you stretch it? Which makes the graph skinnier. And then if it's a fraction, we can tell all those probably. So let's get an example graphing from this. That just tells us how to do it. Oh, remember, we got to get this in there. Because to graph in standard form, they identify the A, B, and C, determine if the graph is up or down. We know how to do that. But do you remember this little formula? You want to get this on your foldable. Because to find the vertex in standard form, it's not staring at us. But you know we have to have the vertex to get started graphing. So To find the vertex, we need to use this little formula, x equals negative b over 2a. When you had it, just stick it in your notes there. That will give you the x of your vertex, and then you'll plug in that value to find the y of your vertex. We'll draw the axis of symmetry like we did the others. We'll find the y-intercept if we need to. Oh, wait a minute. How do you find the y-intercept? Oh, yeah. You set your x equals to 0. So your y-intercept is just sitting out there, isn't it? That's your c. And then we'll sketch the graph. All right. So here we go. Let's graph y equals x squared minus 2x plus 1. Heading out here. Concavity. Look at me. Over down. Ooh, vertex. Okay, that's that little formula. You see the vertex not staring at us in this form. So we're going to do that little x equal negative b over 2a business. So, since b is already negative, negative b will be positive 2. 1, which is just the x of my vertex. I can't just say the vertex is 1. That doesn't do any good. So let's plug that 1 into the original equation for that y value of b. So that will be 1 squared is 1 minus 2 minus 2 is negative 1 plus 1 is 0. So 0 is 1. Line of symmetry always matches the x of my vertex because it's going to go right through my vertex. So what's that equation going to be? X equal my y-intercept is staring at me because when I set my x equal to 0, everything cancels except for that 1 just hanging out there to breeze. 0, 1 is going to be my vertex. My y-intercept. So as far as the graph's concerned, I'm good now. I can throw this over here, this corresponding point. And this is when it's real tempting to make a B. When these are the only 3 points you have, which is how we did the absolute value as well. At that point, you wish you were worried about a B. But now you've got to self-control and think, I've got to make this a U, not a V. Because it's a quadratic. Emphasize the curve. No straight lines here. All right, is this going to be a minimum or a maximum? Minimum. And the output of this minimum value, what's the output of my vertex? 0. It's going to be a minimum value, and the minimum value is going to be 0. So the last form is called, some books call it the factor form. Other books call it the intercept form. The reason for the 2 names is because you derive one from the other. And this equation right here, I'm just going to draw a generic graph here. So that's my xy axis. And let's say this is negative 3 and this is 3. This negative 3 and 3 are the x-intercepts. But when I solve a quadratic equation, those are also going to be they're going to be the intercepts. They're also going to be the solutions. But we get them by factoring those two things right there are going to be my x-intercepts. But notice I have factored the equation. I pulled out a common monomial if I could, and then I factored that equation. So here's the things we know from this form directly. Got a little bit more to say there, so I'll pause and give you a minute to add on that on your foldable. Alright, so in this one then, I wrote in the zeros for you. So the zero is going to be a P0, Q0, axis of symmetry. This is kind of interesting. The axis of symmetry is halfway between the P and the Q. Wait a minute, what does that mean? I said halfway between. Well, it's halfway between because wherever your graph is, I don't want to center it on origin. Wherever the graph is, this right here is your vertex, right? And there's always, it's an axis of symmetry. So whatever this is, its corresponding point is here. If this is my P and this is my Q, then the X of my vertex is going to be right in the middle. So you find that by averaging, which we'll talk about that in a minute, but you could, whenever you want to find what your X of your vertex is, just average your P and Q. Add them together, divide by 2, and that will give you your vertex. Concavity will know, and vertical stretch or shrink will know. Alright, so I want to, hang on, I'm going to hop to one that has a negative in front. Let's do this with the next one. Alright, so let's do this one as a sample in your book. So we'll have at least one with a negative A in it. So our example in our foldable, y equals negative x, parentheses, x minus 4. All right, concavity. My A is what? Negative. It is negative. Oh, yeah. I don't have B's and C's in this problem. So my concavity is down, of course. Now, where are my x-intercepts going to be? Well, you have to look at your factors. How many factors do I have in this problem? How many things are being multiplied together? 2. I've got an x times an x minus 4. 2 factors. So if I have y equals, if I know that y is 0, and I have 2 things multiplied together, let's say I have 3 times blank. What does that blank have to be? What has to be in this blank? To get this times 3 is 0. A 0 has to. If I have 0 equals blank times 5,962 million, what does that blank have to be? A 0. So if I'm looking for my x-intercept, I'm going to set my y equal to 0, right? So this piece is going to be 0. And I have blank times blank. One of those blanks has to be a 0. There's no other way to get a product of 0. So therefore, my x-intercepts are going to be wherever I'm going to either the negative x is a 0, or the x minus 4 is a 0. One of those has to be true. And if I solve each of those, x is 0 here, x is 4 here. That's my 2 x-intercepts. My x-intercepts are going to be at 0. Ready? I'm going to go over. 0 and 4. 1, 2, 3, 4. I know that's to be true. You want to say those are your P and Q from the formula. That's what they are. And then, so my x-intercepts are 0, 0, and 4, 0. That's 2 x-intercepts in this one. My vertex. Well, I can't use negative b over 2a because it's not in standard form. It's not in vertex form, so I can't just look and see the vertex. But what I do know is that the vertex is going to be right exactly in between these two x-intercepts. Well, what's the x value right there that I just drew? What is that value? 2, right here. So I know the vertex, at least the x of the vertex is going to be 2. It's got to. It's got to be on that line right there. So let's plug in 2 and see what y would be. Move back here, and I'm going to stick 2 into my x. So that's going to be negative 2 times 2 minus 4. Negative 2 times negative 2, so that'll be a positive 4. So 2, 4, 1, 2, 3, 4. 2, 4 is my vertex. Does that make sense? It's supposed to open down. Absolutely. So it squares off what we already thought. Active symmetry, of course, will be x equals 2, because it's always x of your vertex. Start with an x because it's a vertical line. Y-intercept, I actually already have it. It's right here. I've already established my y-intercept. It's 0. Again, very tempting to draw a B. Do not draw a B. So is my vertex a maximum or minimum in this problem? Maximum, because it's the highest point on the graph. It's maximum. And what is the output of that vertex? This would be the maximum value. It's the output. It's the y of my vertex. 4. Very good. It's the output of my vertex. Maximum value. All right. Finding the minimum value or maximum value of the function. We know how to do that in arrow. There are word problems in your homework. But let me tell you about this deal. When you have a word problem, the word problem is just going to give you a formula in the word problem. And when it asks what is the to maximize the profit or to maximize something, then you're finding literally it'll be an equation. Let's say it's this one. And I say a company goes by that equation for profit. If it wants to maximize the profit, that, well, wait a minute, this is a negative. Oh, yeah, that will be a maximum moment. Oh, maximize the profit. So that's the outcome. It will be the outcome of your vertex here. That will maximize the profit. Okay? Yeah, this one, I think you'll figure that out on your own. But just mainly know that these word problems, look for the quadratic equation, look for the quadratic, and think of it as a math problem, and then you'll be fine. Don't let the wording scare you. Okay? You got a lot of time to work as is on purpose. Matter of fact, if you want to start with the word problems while I'm in here to help you, you can certainly do that. Go back to the evidence.